And here we've got some examples of ionic substances, one metal and one nonmetal, or one metal and a polyatomic ion. Anytime you see a polyatomic ion, that's your clue that we have something ionic in it. And you can just name them accordingly with their names and their prefixes. Their charges tell you how many there are, with the exception of Roman numerals. You kind of have to balance the charges a little bit if you have transition metals or post-transition metals. The first one, KCl, is just going to be potassium chloride. First element gets its normal name. Second element gets an IDE ending. Tin. This one we have to determine what the charge is. There are 4 chlorines, so it's tin 4. Each chlorine is -1. That's why it's a +4, not because there's 4 of them. Tin 4 chloride. Here we have iron 3 oxide. Each oxygen is -2, which gives you a -6 total of the negative ions. There are 2 ions, each one has to be +3 to balance out that +6 -6. Here's potassium. And you recognize anything in here that has 3 substances in it, Mn and O4. We don't name anything that has 3 different names. That's a polyatomic ion. It's one that you had to memorize, permanganate. Second one down here, barium, polyatomic ion, hydroxide. And then we have another hydroxide here. This one is iron. But iron is a transition metal, so this is going to be iron 3 hydroxide. And that 3 tells us which version of the iron we have. Each hydroxide is -1. There are 3 of them. Iron has to be +3. Here's another example. It looks like there's a lot of different elements in there. Find the polyatomic ion. H2PO4 is polyatomic. Again, forgive the subscripts. They're not working on this program. But we have sodium, dihydrogen, phosphate. And dihydrogen phosphate is the name of one thing. We're not naming this thing with 3 names. Dihydrogen phosphate is a polyatomic ion. Here's 2 polyatomic ions. This is one of our only positive ones. Ammonium dichromate. Calcium does not need a Roman numeral because it's an alkaline earth metal. That's hypochlorite. Chromium, however, does need a Roman numeral. Nitrates, NO3 is -1. There are 3 of them. Chromium is +3. Chromium 3 nitrate. Wrapping up Chapter 2, we're going to look at different types of naming, and we'll start off by highlighting this first part here. We're going to start with the covalent naming system, which uses prefixes except for mono and the first element to tell you what all the elements are. So the first one we get, carbon dioxide. Next one we get is P2O5, which is going to be diphosphorus. Pentaoxide or pentoxide. I don't know if there's a real penta or pentoxide. Either one of those is fine. And we know all of these are covalent because they're made up of nonmetals on the right side of the periodic table. 2 nitrogens here is dinitrogen. 3 oxygens is trioxide. 2 chlorines, so dichlorine. And Then 7 is heptaoxide. So you need to know what the prefixes of these are and the general construct. Here's sulfur, and this is an example where we're not using mono in the first element, trioxide. And then bromine trifluoride. So those guys are covalent. Next one we're going to get to. And here we have a mixture of a bunch of different things put together. So you have to decide if it's ionic, covalent, Roman numerals or not. All goes together. PCl5, 2 nonmetals. This is phosphorus. Penta is 5. Pentachloride. HClO2. This is actually one you don't need to know right now. This is actually an acid, which we will talk about later. And it's not a strong acid, so it's not one we have to memorize. So we're going to pause on that one, and we'll come back to it in a little bit here. Ni is nickel. Nickel needs a Roman numeral. This is nickel 2. Nitrate. Sb2S3. Sb, a lesser known metal, antimony. Does need a polyatomic ion, or I'm sorry, does need a Roman numeral. Antimony 3 sulfide, because each sulfur is -2. Gives you a +6, -6 balance. XeF4, ignoring for the fact that this is a noble gas, it is still a nonmetal, so it's just covalent. These can do that. Xenon, tetrafluoride. Polyatomic ions here, ammonium, hydroxide, sodium is the first element, polyatomic ion C2H3, that should be C2H3O2. There's a little typo. Sodium acetate. Next one, sodium. This one has two different names, that HCO3. We can call it bicarbonate or hydrogen carbonate. That would work fine. This last one, this is not a trick. These happen, so just follow the general construct. Lithium is a metal. Hydrogen, it's coming second this time. We're just going to change the name. It's hydride. And if we follow the logic here, lithium is +1. Its positive ions come first. That's actually telling us that this hydrogen is -1. And that's not a problem. Hydrogens can be -1 and form ionic compounds. Very rare, but we will see them from time to time. Lithium hydride. Now we need to write formulas going backwards, mixed up, ionic and covalent. Sodium chloride, we need to keep track of the charges here. +1 and -1. That's going to be NaCl. Calcium fluoride, +2 -1, those are ionic. CaF2. Iron 3 nitrate. Iron, they're telling us, is +3. Nitrate is -1. Balance those out, we get FeNO3 3. Copper 1, that's copper is +1. Chlorine is -1. CuCl, one of each. Barium is +2. We can look that up. Phosphate is -3. We need those to get to 6. So I need 3 bariums and 2 phosphates. 2 of the polyatomics going in parentheses. Tin 4 +4. Oxygen is -2. 4 is the common multiple there, so I just need one of the tins, but I will need 2 oxygens to balance it out. SnO2. Dinitrogen tetraoxide. No charges here. They're just telling me 2 nitrogens, 4 oxygens. So N2O4. And again, more polyatomic ions here. Looks like we only had 1 covalent compound. In that list, the rest of them are ionic. Ammonium acetate. Ammonium is a +1 ion. Acetate is a -1 ion, so we just need 1 of each. NH4 is ammonium. CH3COO, and you'll recall there's 2 different ways to write that. C2H3O2 is the other one. NH4CH3COO, ammonium acetate. There's no way around it. You just need a lot of practice with these to name a lot of things throughout the year. And you need to get really good at it. The last thing we're going to here, this is just a list for you to memorize. These are the strong acids. There are thousands of weak ones. There are only 8 strong ones, which we're going to work with. Some in Chapter 4 and then a lot throughout the rest of the year. Very important to know these names. You don't need to know how the names are formed or what the construct is for acids, but you do need to have these 8 strong acids memorized, and that'll round up our naming system.